Hello everyone and welcome back to NotesNaka. Today is day 16 of the lead coding challenge, and for today's problem we have odd even linked list. So what we have to do in this problem is we will be given a linked list and we have to arrange it so that all the odd nodes occur before the even nodes. And by nodes here we mean the node number, not the data inside it. So let's check out the logic behind this problem on pen and paper. For today's question, we will be given a linked list and we have to sort it in a manner that all the odd nodes occur before the even nodes. Now what nodes is here is the node number, not the data inside the node. So after rearranging this, what we will have is 1, 3, 5, 2 and 4. So this is what we want to create from this array, and we will do it in place, and we will do it in big O of n time complexity. So what we basically are trying to do is, suppose this is, we make two pointers, okay, like this odd and this even. So what we have now is this is odd, this is even. Also this node will always be the beginning of the even. So we mark it as even, that means start of even. So now what we do is we want to connect odd with 3, that is evens next. So we will do odd of next is equal to even of next. So after this step, what we will have is 1 will be connected to 3, also 2 is also still connected to 3, and 3 is connected to 4. Now what we want to do is connect 2 with 4 and 3 with 2. So for that what we will do is, now even of next is equal to odd of next of next. So odd of next of next. So now what we will have is 1 is connected to 3 and 2 is connected to 4 and 3 is still connected to 4. Now we want to change 3's path to 2. So for doing this step, what we do is odd of next is this one. Now we will always connect it to the starting of the even node. We will not connect it to any other node. So for that, odd of next is equal to s even. That is what we want to do. So after doing these three steps, what we will have is 1, 3, 2 and 4. And after this, what we will do is make odd is equal to odd of next. So this will become our new odd, and this is still s even. It will stay s even, we will not change it, and even will be changed to evens of next. So this one will become even. And in our main list we have 5 attached over here. Now we want to change the position of 5. So to do this, what we will do is, now in the next iteration, what we will do is, now odd is this, even is this. We will follow the same steps. But now what we will do is, after this step, when this step is done, we will have 1, 3, 2, and then odd of next will be 5. So odd of next will be 5, and 5's next will be null, and we will have 2 and 4 separately. Now 4 is initially pointing to 5, but what we want to do now is make 4 point to null and 5 point to 2. So to do this step, now what the problem is, if we access odd of next now, it will access null, and that's not what we want to access. So for that reason, what we will try and do is, if even of next, at any point if even of next is equal to null, means that that is the last node. Now after connecting odd, there is nothing we can do. So in such case, what we will do is make even of next as null, and then make odd of next of next as even start. So what we basically did is put a condition wherever evens next is null. Evens next of next is null. At that point, what that means is we have 4, 5 and then null. We don't have anything after that. So what we want to do in such cases is that we want to make even of next null, and we want to make odd connect to the start of the even list. So as even. So that is what we want to do now. So we will add a condition for such cases. Now if it is not even, that means even of next is not null. So we will simply make even of, we will simply do this step, even of next is equal to odd of next and continue with the procedure. So this was, so what we have to handle is even number of nodes. If there is even number of nodes in the linked list, then we simply do these steps and there is nothing else that we need to do. If there are odd number of steps, then we make a condition over here and make the last node point to as even and then return directly over there. We will not go further on after that. And besides all of this, the two cases can be if there is nothing in the linked list. If linked list is empty, then we just return. Another, if only one node is present in the linked list, then we simply return, we do not do anything. And if only 2 nodes are present, in such case also there is nothing that we need to do and we just return the head of the linked list and it's over. So I hope you understood the main logic behind this problem, and let's check out the code now. I hope you guys understood the basic logic. Now let's look at the code. So this is the code. First thing first, if head is null, then we will return head. If head of next is null, that means only one node is present, then we will return head. If head of next is null, that means we have 2 nodes, then there is also nothing we can do about the linked list and we just return head. After that comes the main logic. So what we are trying to do here is we make a initialize a node to head and even to a head so that the head does not change and we can return head at the end. So we have odd, even and e start. E start means the starting of the even list. So that is head of next and head of next. So the first one is odd and the second one is even. After that, we iterate through each and every element of each and every node of the linked list. And here what we do is if odd of next is not equal to null, we are trying to access odd of next inside our code, so that cannot be null. And if even of next is not equal to null, then we can go inside and we can see the first thing we do is odd of next is even of next. We first connect odd of next with even of next. So even of next will be odd number. So we just connect that. And after that, if even of next is not equal to null. So this is the case where we will handle odd number of nodes in our linked list. If there are odd number of nodes, then even of next in the last iteration will be equal to null, and we cannot access the pointer directly. We cannot access odd of next that will give us a null pointer reference error. So that is not what we want to do. So if it is equal to null, then we will make even of next is equal to null directly, and odd of next is equal to e start. That means whatever was after the last element that was left will be connected to the e start now, and it has already been connected to the odd list in this line. So we just do this step and return head. We do not go further on. That means our list has ended and we just return head. And if that is not the case, if there are not odd number of elements, then even of next will not be null even in the last case. So what we will do in such case is even of next is equal to odd of next, the normal one. We will just follow this over here. Even of next is equal to null, but even of next we will make odd of next. And after that, odd of next is e of start. So we are connecting it to the start of the even list. And at last we are making odd is equal to odd of next and even is equal to even of next for the next iteration. and after that it will again check these conditions. If these conditions are fulfilled, then only it will go inside the loop, and if not, it will just return the head. So this was the code. If we run it, we can see that we have the same answer and it has also been accepted. So this was the code for today's problem. I hope you understood, and if you liked this video, then give us a thumbs up. Also subscribe to our channel, and if you have any feedback, then do leave it down in the comment section. And thank you for watching and have a nice day. Bye bye. Take care.